Welcome to this video on simplifying square roots with numbers and variables. Let's begin. Example 1. What is the square root of x to the fourth power? So I'm going to show you two different ways to think about this. One is to think about how to rewrite x to the fourth as a product. So x to the fourth is 1, 2, 3, 4 x's, right? So if I take the square root of x to the fourth, I'm taking the square root of these 4 x's. So remember from the last video, right, we said that pairs of the same number, right, or in this case the same variable, can escape. So what does that mean? That means that we have one pair of x's that can escape, and then we have a second pair of x's that can escape. Okay? So what does that mean that our final answer is? Well, we're going to have one x on the outside, two x's on the outside, and nothing left over, right? There's nothing left on the inside. So what is x times x? Well, x times x is just x squared. So that would be our final answer. Okay, so that is one way to understand and look at this. Okay, another way to think about this is if you think about the square root, right, we can put a 2 here. We never do, right? But the square root means, right, the 2 means that we're taking the square root. So what I can do is I can divide this number right here, this 4, I can divide 4 by the number out here, 2. So 4 divided by 2 is 2. So that is going to tell me that my final answer is x squared. Okay, so again, you have two ways of doing it. You can think about it this way, right, where you're just rewriting the exponent as products, right, and then pairs of values escape. Okay, you can also think about dividing the exponent by the root. All right, let's do this next one. So here we have y to the 7th power. Okay, again, I'm going to do both methods. So we have 1, 2, 3, 4, 5, 6, 7. Okay, so pairs of these values are going to escape. So we have 1, 2, 3 pairs, right? And then we have this odd man out. He's trapped there because he doesn't have a buddy. Okay, so 1, 2, 3 y's escape. There is one y still under the radical. So I can rewrite this as y to the third times the square root of y. Okay, now you might notice, right, as my exponent gets bigger, this method gets a little bit more cumbersome, right? If I said y to the 70th power, right, 70, you would definitely not be able to use this method. Okay, so you're going to probably need to learn this other method. So let's think about it this way. So we have y to the 7th, right, and we're taking the square root. So what we're going to do is we're going to take 7 and we're going to divide by 2. Okay, so 2 goes into 7 3 times, right? And then remember remainders, remember that? Right, there is 1 left over when I divide by 2. Okay, so I have 3 remainder 1. So this is going to go, this is the exponent on the outside of the radical, okay? And this is the exponent on the inside of the radical. So let me show you what I mean. So the outside is going to be y to the 3rd power. On the inside, it's going to be y to the 1st power, or just y. Okay, notice that this is exactly the same as the answer that I got from the other method. Okay, so if this remainder thing is confusing you, if it's been too long, I will post a video to remind you how to do long division and get remainders just to jog your memory. All right, let's do another example. So here we have x to the 6th, y to the 11th. So this time, y to the 11th, that's really getting cumbersome. So I'm not going to use that first method where we rewrite everything as multiplication. I'm just going to start by using the method where we divide. Okay? So remember, there's really a 2 here, right? So remember I can also break these up. So I have the square root of 6 times the square root of, the square root of x to the 6th times the square root of y to the 11th. Okay, so here we're going to have x to the 6 over 2, okay, which is just x to the 3rd. Here we're going to have y to the 11 over 2. All right, well, let's think about 11 over 2. So 11 divided by 2, 2 goes into 11 5 times. That gives us 10. 11 minus 10, right, is 1. So what does that mean? Well, this means that this is the exponent on the outside of the radical, and 1 is going to be the exponent on the inside of the radical. Okay, so this is times y to the 5th on the outside of the radical, y to the first power, or just y on the inside. Okay, so the final answer here is x to the 3rd, y to the 5th, times the square root of y. That is our final answer. 64x to the 7th. Notice in this example we are combining our numbers and our variables. But we can still use that nice property that we have. Remember that we have a property that says this is equal to the square root of 64 times the square root of x to the 7th. Okay, so the square root of 64, we got lucky here in the sense that this is a perfect square. The square root of 64 is 8, so that's pretty simple. Okay, and if we're looking at the square root of x to the 7th, right, then we have to think about dividing 7 by 2. So 2 goes into 7 3 times. 3 times 2 is 6. 7 minus 6 is 1, so there's 1 left over. So remember, this is the exponent on the outside of the radical, and 1 is the exponent on the inside of the radical. Okay, so I can rewrite this expression here, the square root of x to the 7th power. I can rewrite that as x to the 3rd power, right, he's on the outside, times the square root of x to the 1st power, or just x. So we'll bring this down. So we have 8 times x to the 3rd square roots of x. So my final answer is 8x to the 3rd times the square root of x. That is our final answer.